Let us discuss today one of the important topic under formal language and automata theory, that is pumping lemma. Pumping lemma for regular set. Regular set. So, if you see here, there is a generalized theorem. What is that generalized theorem here? So, if you see the generalized theorem here, that is, let L be a regular language, then there exists a number n such that for every string W belongs to L and W is divided into three parts, X, Y and Z, so that W equal to X, Y, Z, and follows the following properties. Following property. So what are the properties? I write again here. Let L be a regular language. Okay. And there exists a number n such that what is that? For every string W belongs to L and let W equal to X, Y, Z. X, Y and Z are ordered component or parts of the string X. So what is that idea? Let L be the regular language and there exists a number n such that for every string W belongs to L and let W is equal to X, Y, Z. X, Y and Z are ordered components or parts of the string W. Obey the following properties. Following properties. What are the properties? Number one, Y should not be equal to epsilon, that is, the length of Y must be greater than 0. Number two, the length of XY must be less than or equal to n. Third, x y to the power k z belongs to L, where k is greater than equal to 0. This is the generalized theorem of pumping lemma, right? Pumping lemma for the regular language. Now our next topic is that under this, what for this pumping lemma come up? Now the pumping lemma, we have to discuss, let it is called A and B. Pumping lemma used to show that some languages are not regular. So for that, what we are going to do that, let we have language here, let so given here L, that is a to the power n, b to the power n, n greater than equal to 0. Okay, let L is the regular language. Let L is the regular language. Again I repeat what we are going to do. Pumping lemma used to show that some languages are not regular. Let us take one example here. L is equal to 8, what is that language? A to the power n, b to the power n, such that n greater than equal to 0. Let L is the regular language. And what you have to see that, let L is the regular language. Point number 1. Choose a number, choose n here, n equal to 3. You have to take suitable integer and choose n here. Let here n equal to 3. What is we have to do that? Let w is x square b square string and w is belongs to a true and w is belongs to a. Next part is that divide into 3 parts. So what is the idea? Divide into 3 parts. So we will divide now. What is the string here? String w, that is in L, that is a square b square. We can write here that is a b b. Let x equal to a, y is equal to a, and z is equal to b square. So if you combine all this, So what is that idea? That is W equal to X, Y, Z, A, B square. Now test all the three properties of the regular language. Three properties of the language. Number one, y should not be equal to x. Let us check here. And also we have written that the length of y is greater than 0. Let us check. Y is equal to what we have written here. Y is equal to A. So the length of y is greater than 0. Also, y is not equal to epsilon. It is true. Right. Property number 2. What is the property number 2? Y, x, y, the length of xy less than equal to n. Let us check. Let us check here. So, if you see this length here, A, which is equal to 2, is less than equal to 2 is less than equal to 3. So it is property number 3. So what is the property number 3? Pumping a new string. What is that string here? X, y to the power k, z, where k greater than equal to 0. What is that idea? Now, let us say, what is that? Let us check here. X, y to the power k, z belongs to L or not. Choose here. Choose k equal to 2. You can choose anything, any number here. K equal to 0 also. K equal to 2. So what is happening there? Then, okay, k, if you see that x, y square, z, that is equal to a whole square and b square, that is equal to a cube b square. And you can see that this a square b, the new string, the new string does not belongs to L. What we have prettily assumed here, we have assumed it that L is a regular language, because it violates the property number T. It does not belong to this. That is equal to W. Now what we are finding here, that x, y square, z does not belong to L. Property number 3 is violated. Hence, what is hence? Hence the language what we have taken here, whichever the language we have taken here, assumption that L is a regular language, but we conclude that the new string which is pumped from the W, that is equal to xyz, pumped new string xy to the power kz does not belongs to L. It contradicts to our assumption. This was our assumption, and it proved that this given language L is not the regular.